For this, we're going to solve this paper, October-November 2023, Pure 1, Variant 2. Okay. We go into the first question. It's a question about the binomial theorem. And for that, we have our formula NCR, A power n minus r, B power r. A is always the first term, B is always the second term. The coefficient of x cubed in the expansion of this, so we need to find what x cubed would be. So obviously we want our n is obviously 5, c we don't know what r is, 3 power 5 minus r, and 2ax power r. We want the power of x to be x power 3, and so in this case, because this is the only thing that has the x, we're just going to make r equals 3, right? And we're going to get 5 combination 3 power 5 minus 3 and 2ax power 3, and that's going to give us the coefficient of x cubed in this expansion. That is 6 times the coefficient of x squared in this expansion. So in this expansion, it's going to look something like 6cr 2 power n 6 minus r, and then ax power r. Again, this is the only thing that has x, and we want the coefficient of x squared, so r here will be 2, and we're basically looking at 6c2 2 power 6 minus 2, and then ax power 2. And so that is our equation done. Now we can just find the values for all of them. So 5c3 is just going to be 10, and then 3 squared is just 9, and then 2 cubed is 8, and then times a cubed times x cubed will give us the coefficient of x. So we're only interested in the coefficient, so this is the coefficient, is equal to 6 times 6 combination 2, which is 15, and then times 2 power 6 minus 2, which is 2 power 4, which is just 16, times a squared x squared. We're only interested in the coefficient, so we're going to remove this as well, and we end up with 10 times 9 times 8, which is 728 cubed, equals 6 times 15 times 16, which is 1440 a squared, over 1440 over 1440, right? And this is just going to give us a squared equals 720 divided by 1440 a cubed. So a squared equals to 0.5 a cubed, and here what we can do is just take this to the other side, and we get 0 equals 0.5 a cubed minus a squared. We can factorize our a, so a squared 0.5 a minus 1 equals 0, and so a squared equals 0 and 0.5 a minus 1 equals 0, which just tells us that a equals 0 from this, and from this one 0.5 a equals 1 over 0.5 over 0.5, a would be 2, and that's the answer for our first part. For this next question, we just have to find the exact solution, so we need to find what x is in this case. So remember, because this is in pi, you should be smart enough to change your calculator to radian. We are dealing with radians and not degrees, so 1 over 6 pi plus tan inverse of 4x equals negative cos inverse of root 3 over 2, and we can just do this straight away, and cos inverse of root 3 over 2 will give us pi over 6, so because negative is going to be negative pi over 6, and so we have pi over 6 here plus tan inverse of 4x equals pi over 6 here as well, and then we can just take this to the other side. Sorry, this is negative pi over 6. Take this to the other side, and this becomes tan inverse of 4x equals negative 2 pi over 6, because just negative pi over 6 minus pi over 6, negative 2 pi over 6, or just negative pi over 3. That equals to tan inverse of 4x. Therefore, if you apply tan on both sides, become 4x equals tan of negative pi over 3. So tan of negative pi over 3, which will give us 4x equals negative root 3, and then over 4 over 4. So x will just equal negative root 3 over 4, and that's going to be your answer for x. For the third part, the third question, the equation of a curve is such that dy dx is half x plus 72 over x power 4. Remember, dy dx tells us the gradient of the tangent to the curve at a certain point x, and we know that the curve passes through the point 2, 8. We need to find the equation normal to the curve at P. Meaning what? If we had a curve and this was our point P, we want to find the equation of the normal to the curve. Okay? Obviously, the normal means it's perpendicular to the tangent. And so, if we get the gradient of the tangent, we should know m1, m2 equals negative 1 for perpendicular lines. And so, what we'll start off with is finding the gradient of the tangent at x equals 2. So half 2 plus 72 over 2 power 4. This just becomes 1 plus 72 over 16, which is 9 over 2. Add 1 to that, you're going to get 5.5. So the gradient of the tangent at that point is 5.5. We can find the gradient of the normal to the tangent as well at that point. So 5.5 m2 equals negative 1 over 5.5 over 5.5, and we're going to get negative 2 over 11. So m2 equals negative 2 over 11. That's the gradient of the normal line. Yeah? So y equals to negative 2 over 11x plus c, and then you can put in your x and y coordinates, which is 2 and 8, which then you can plug them in because it passes through that point, right? So 8 equals to negative 2 over 11 times 2 plus c. This will become 8 equals negative 4 over 11 plus c. Take this to the other side. C would equal to 8 plus 4 over 11, which would be 92 over 11. So c equals to 92 over 11, and then we can get our equation, which is going to be y equals negative 2 over 11x plus 92 over 11, and that's going to be your answer. On the next part, we have find the equation of the curve. And so remember, if you have the derivative of your curve, and in order to find the equation of the original curve, you will have to integrate it, right? So you would integrate this half x plus 72 over x power 4. But firstly, I would like to remove all the denominators, meaning bring them to the top. We end up getting half x plus 72 x power negative 4. And integrating this would give us what? You add the power on the top and you divide by that same added power, right? So half x power 1 plus 1 over 1 plus 1, and then plus 72 x power negative 4 plus 1 over negative 4 plus 1. And that's going to be the integration. Remember, this is indefinite, meaning there are no limits here. And so you're going to add c at the end, which you'll have to find later. So y equals to that. This will just become half x squared over 2 plus 72 x power negative 3 over negative 3. And then this becomes 1 over 4x squared minus 72 over 3 is just 24. So minus 24 x power negative 3 plus c. And how would we find the plus c? We have a point that the curve passes through, which is 2, 8. And we do the same thing that we used to find c in the other one. So 2, 8. 8 equals half, a quarter. 2 squared minus 24. 2 power negative 3 plus c. This is going to become 8 equals 2 squared is 4. Then this is just 1. 1 over 4 times 4. Minus 3, because 24 over 2 power 3. Yeah, this is just 24 over 2 power 3, which is 24 over 8, which is just 3, plus c. And 8 equals negative 2 plus c. Take this to the other side. C equals 10. And so we end up getting y equals to 1 over 4x squared minus 24 over x cubed plus 10. And that's going to be our equation of the curve. The next part here, the diagram shows the shape of a coin. The three arcs AB, AC, and CA are parts of a circle with centers C, A, and B respectively. So basically AB would be with center C, AC would be with center A, and BC would be with center A. AC would be with center B, sorry. Yeah. ABC is an equilateral triangle. That means this right here is an equilateral triangle, which means each of these is 2 centimeters. And remember, the angle is going to be 60 degrees. Or because this you have to use your radians, then 60 degrees is just pi over 3. Because it's equilateral, meaning all sides are the same and all angles are the same as well. Pi over 3, pi over 3. This tells us that our radius is 2. This is our sector, right? Just one of the sectors. Our radius is going to be 2 and the angle is going to be pi over 3. So perimeter of the coin, remember, perimeter you're just looking at the arc length, 3 of those arc lengths. Arc length equals to theta r, which just means pi over 3 times 2. Yes? And remember, we have 3 of these arcs which are all the same. So just multiply by 3 at the end and we're just going to get 2 pi. And that's going to be the perimeter of the coin. Find the area of the face ABC, giving the answer in terms of pi and root 3. So now we have to find the area of these. Meaning here what we're planning to do is you want to find the area of the triangle and the area of these minor segments. Now, how do we find the area of the minor? Obviously, these minor segments are all equal, right? This is like a very symmetrical coin. And so if we just find the area of one of the minor segments, multiply that by 3, then find the area of the triangle, and we're done, right? So let's just look at the triangle first. And for the triangle, we're going to do half times side 1 times side 2 times sine theta, right? So side 1, this part here, side 2, and the angle in between them. So half times 2 times 2 times sine pi over 3. And that's going to give us the area of the triangle. For the area of the bigger sector, so this entire thing, including that triangle in the middle, is going to just be half r squared theta. So half times r squared times theta, which is just half times 2 squared times pi over 3. This is going to be 2 pi over 3, because this becomes 4 over 2 is 2, so 2 pi over 3. And this thing right here is going to be sine pi over 3 is just root 3 over 2. So this is just going to be root 3. This part right here, half times 2 times 2 times sine pi over 3 is just root 3. And so if you want to find the area of the minor segment, remember this is the area of the triangle, this is the area of the whole thing. Yeah? And if you just want to find this, you will take the area of the whole thing minus the area of the triangle. So 2 pi over 3 minus root 3. And that will give us the area of this small segment right here. And what we will do now, take that area, multiply that by 3. We're going to end up with 2 pi minus 3 root 3. And then we add the area of the triangle. So root 3. So basically we multiplied this thing by 3. We got the minor segments. And then we also added the area of the triangle at the end. And so we end up getting this, which is just 2 pi minus 2 root 3. Negative 3 root 3 plus root 3 is just negative 2 root 3. And that's going to be your answer for this section. Next part, the first, second, and third terms of a geometric progression are sine theta, cos theta, and 2 minus sine theta respectively. Meaning, sine theta is the first, cos theta is the second, and 2 minus sine theta is the third. And basically what a geometric progression is you have your first term a, we call it, and then to get to the next one, we need to multiply by a certain constant r. and you will multiply from the second to the third by the same constant r, right? So sine to cos theta, what would be multiplied by? Sine times something equals cos theta. And if you want to find r, you'll just do over sine, so cos over sine. And that's what we know our r is. Yes? And so we need to get that here as well. So cos theta times cos theta over sine theta should equal to 2 minus sine theta. Yeah? So we need to find the value of theta that would give us this. This is just going to be cos square theta over sine theta equals 2 minus sine theta. Remember, always start removing all the denominators. So cos square theta equals sine theta, 2 minus sine theta, I took it up. We can expand this. Cos square theta equals 2 sine theta minus sine square theta. But here now we're stuck. So we could just change this into sine so that we can work with it, right? So remember our identities. Sine square plus cos square equals 1. And so cos square equals 1 minus sine squared, which just means this is 1 minus sine square theta equals to 2 sine theta minus sine square theta. Take this to the other side. You're going to just negative sine square theta plus sine square theta are just going to cancel out. And so we end up with 1 equals 2 sine theta over 2 sine theta equals a half. And then with this we can find theta equals to sine inverse of a half. And do we need that in radians? Yes, we need that in radians, and it's an acute angle. Acute angle means it is lesser than 90 degrees. So sine inverse of 0.5, which is just going to be pi over 6. This is less than 90 degrees, less than pi over 2, which means this is an acute angle. Yes? And so our answer for this, theta, is pi over 6. Why did they have to specify it's an acute angle? Because remember, sine, you can get your symmetric angles by doing 180 minus theta, which means you could get pi over 6, or you could also get 5 pi over 6. Yeah? These are going to give you the same value. They're both going to give you half. If you sine this and sine this, they're both going to give you half. But this is not an acute angle. This is an obtuse angle. And so your answer is just going to be theta equals pi over 6. Okay? For the next part, we just need to use the value that we got above. So theta equals pi over 6. And then find the sum of the first 10 terms of the progression. Remember, it's a geometric progression. So take care of that. So just Sn equals a 1 minus r power n over 1 minus r. That's the formula of getting the sum of the first n terms. And so S10 would just be a, which was the first term, and the first term here was sine theta. So sine of pi over 6, and then times 1 minus r, which was cos theta over sine theta. So cos pi over 6 over sine pi over 6, cos pi over 6 over sine pi over 6, power n, this thing alone power n, which is power 10, and then this entire thing over 1 minus cos pi over 6 over sine pi over 6. Okay, and this is just going to be sine pi over 6 is just 0.5. This thing right here, cos pi over 6 over sine pi over 6 is root 3. So 1 minus root 3 power 10 over 1 minus root 3. And that's going to give you, put in your calculator, so root 3 power 10, 1 minus that, times 0.5, divide by 1 minus root 3. And that's going to give you negative 121 over 1 minus root 3, which is just 121 over root 3 minus 1. And you needed it in this form, where b is going to be 121 and c is going to be 3. Yeah, and that's going to be your answer. For this part, we have an equation of a curve. Let's just quickly sketch how it would look like. It would look something along the lines of something like this, because it's a u, since a is 1, it's a quadratic equation. We need to find the coordinates of the minimum point of the curve. Now, a characteristic of the minimum point is that the gradient of the tangent is 0, and the way you find the gradient of the tangent from the formula is find your dy over dx. So dy over dx in this case is going to be 2x minus 8, and we just need that to be 0. So 2x equals 8 over 2 over 2, x will equal 4. So we know the coordinates of x is 4, we just need to find y now. How do we find the coordinates of y? We just plug in this 4 into this formula, and we end up getting 4 squared minus 8 times 4 plus 5. This is just 16 minus 32 plus 5, which is just negative 11. And so the coordinates here are going to be 4 and negative 11. Okay. So after this we go on to part B. The curve is stretched by a factor of 2 parallel to the y-axis, and then is translated by 4 and 1. So if you're looking at a single point, if you have a point A, B, what happens here is, first, stretch factor of 2 parallel to y-axis, meaning every y becomes 2y, so you're multiplying the y by 2. And so this b will just be multiplied by 2, and this will become a times 2b, a and 2b, sorry. And then it's translated to the right, so if a was 1, it will now become 5. So it's translated to the right by 4 units. So a plus 4 here, and then this is going to be 2b plus 1. It's translated up by 1. And so any point that we had of the original curve is now going to look like this. Any point AB will become like this. So we had our point 4 and negative 11. What's going to happen to this is your 4 is going to add 4 to it. So 4 plus 4, and then you're going to have 2 times negative 11 plus 1, which is going to become 8, and negative 22 plus 1 is negative 21. And that's going to be your new minimum point for the transformed curve. Okay. Now find the equation of the transformed curve, giving your answer in the form y equals to ax squared plus bx plus c, where a, b, and c are integers to be found. Now there are a few ways to do this. I'm going to give you 2 ways from it. One is using the vertex itself, right? But this wouldn't be very precise. You have to have a little bit more knowledge for this, because of a certain thing that happened, which was basically this thing right here. Yeah, and I'm going to show it to you. So remember, in a vertex normally you have if you want to convert the vertex to your completing the square format, you're going to have something like x minus p squared plus q, where this is your p and this is your q. So x minus 8 squared minus 21, and your equation is going to look like this. However, because you multiplied the initial thing by 2, right, your curve is stretched by a factor of 2, that means your a, this thing right here, becomes 2a. So if you had nothing at the start, you're going to end up with 2 here. So this is going to be your completing the square format of the equation. Another way of doing it is looking at the initial one. So the vertex of the initial one was 4 and negative 11, which again means x minus 4 squared minus 11. And then you apply your things to it, right? You apply your transformations to it. So x minus 4 squared minus 11. And then you say, okay, first one, the curve is stretched by a factor of 2 parallel to the y-axis, meaning every y becomes 2y. And here what happens is, obviously this is equal to y. So you're multiplying the entire thing by 2, which just means you're multiplying 2 here and you're multiplying 2 here, which just becomes 2 bracket x minus 4 squared minus 22. And then what happens is it translates to the right by 4 units. But remember, transformations of x, you will be inversing them. So x, you would assume you would have to add 4 because you're translating to the right, but instead you would subtract 4. X becomes x minus 4, and so this just becomes 2. Every x becomes x minus 4, then subtract 4 at the end, squared, minus 22, and then obviously y becomes y plus 1 because you're translating it up by 1 unit as well, right? and this then ends up becoming 2 bracket x minus 4 minus 4, which is x minus 8 squared, minus 22 plus 1, which just becomes minus 21. So 2 bracket x minus 8 squared minus 21. So same thing we got, but in two different ways, where this requires a little bit more knowledge in the multiplying by 2. I feel like this one is easier. And then after this, you can just expand it because you wanted to write it in the general quadratic format. And so we just expand this. So 2, we can square this side. So x squared minus 16x plus 64 minus 21. Open the bracket, 2x squared minus 32x plus 128 minus 21. This ends up becoming 2x squared minus 32x plus 107. And that's going to be your y. So y equals to this thing right here. For this next part, we need to do verifying identity. So obviously we just need to multiply this in, and we should get this. So remember, how do you multiply in? You take the first term with the first term, first term with the second term, first term with the third term, and then do the same thing for the other one. Yeah, and these are all multiplications that you're doing. So 2x times 4x squared plus 2x times 2x plus 2x times negative 1, and then minus 1 4x squared minus 1 2x minus 1 minus 1. 2x times 4x is 8x cubed plus 4x squared minus 2x minus 4x squared minus 2x plus 1. This ends up becoming 8x cubed plus 4x squared minus 4x squared, so just cancel out. Negative 2x, negative 2x, negative 4x, and then plus 1. So 8x cubed minus 4x plus 1. And that gives you what we had to find. Then the second part talks about proving an identity, tan square theta plus 1 over tan square theta minus 1, and we need to somehow end up with this. Now, whenever you get something like this, which has tan, I would first convert all the tans into sine over cos. So you know your identity, tan equals sine over cos. You need to be very good with this and the other one, obviously. Okay, and we can start off by this. So tan square is just sine square over cos square, so going to get sine squared over cos squared plus 1 over sine squared over cos squared minus 1. And I want to treat the numerator and the denominator differently and make them one fraction. So remember, firstly, if you have tan, always convert to sine over cos, at least most of the time, because usually what you want at the end does not have a sine over cos. And then secondly, if you have two fractions, in this case these are two fractions, we always have to convert them into 1. And so we convert this into 1. Let's do the numerator first. This will become cos squared at the bottom, and then at the top is going to be sine squared plus cos squared. Yeah, I made this into one fraction. Same thing below here. This is going to be cos squared at the bottom and sine squared minus cos squared. So we end up having sine squared plus cos squared over cos squared divided by sine squared minus cos squared over cos squared. Remember, divide, you can just change it to a multiply and reciprocating the other one. So sine squared plus cos squared over cos squared times cos squared over sine squared minus cos squared. These two cancel out. Sine squared plus cos squared is just 1 from this identity. So we end up getting 1 over sine squared minus cos squared. Then you have to be very precise with exactly what you need. So if you look at the other side, we don't have a sine square anymore, right? And so we want to convert that sine square into a cos square realistically. So sine square from this is just 1 minus cos squared. So we end up getting 1 over 1 minus cos squared minus cos squared, right? Which just becomes 1 over 1 minus 2 cos squared. And that's going to be our thing that we required at the start. And that's our identity done. Then the last part we're going to use, usually they give us the same exact identity, equals to something. So obviously this thing right here, we got it to be this. So 1 over 1 minus 2 cos squared. So This is just 1 over 1 minus 2 cos square theta equals 4 cos theta, and you need to solve this. The way we do this is remove the denominators first, so take it up here. 1 equals 4 cos theta 1 minus 2 cos square theta. This becomes 1 equals 4 cos theta minus 8 cos cube theta, right? Minus 8 cos cube theta. Take this to the other side, and this ends up becoming negative 8 cos cube theta plus 4 cos theta minus 1 equals 0. And then after that we can just visualize this and look at what they did in A, right? They gave us 8x cubed minus 4x plus 1 is equivalent to this. Now they wouldn't just ask you it just like this, right? So you have gotten to a stage where you have a cubic equation and you don't know how to solve it, but look at the information they gave you above. So 8x cubed minus 4x plus 1, 8 cos cube 4 cos 1, very similar, right? Just maybe change the signs. So 8 cos cube theta minus 4 cos theta plus 1, these are the same thing still. And up here we had 8x cubed minus 4x plus 1, 8x cubed minus 4x plus 1. These look exactly the same, just that we have changed the x for the cos, right? And this is just the same as 2x minus 1, 4x squared plus 2x minus 1. So 2 cos theta minus 1 and 4 cos square theta plus 2 cos theta minus 1. 4 cos square theta plus 2 cos theta minus 1, right? Just confirming, yeah. And that will be equal to 0. So we have our first bracket equals to 0 and our second bracket equals to 0. So 2 cos theta minus 1 equals 0 and 4 cos square theta plus 2 cos theta minus 1 equals 0. Remember, this is just a form of a quadratic because this is twice the power of this. And so we can change this into 4u squared plus 2u minus 1 equals 0. And this side is going to be cos theta equals 1 over 2. Here we can find the theta straight away. Cos inverse of 0.5. But remember, this is in degrees. And we had previously changed it into radians, so we just would need to change it back into degrees. And cos inverse of 0.5 is just 60 degrees. Yes. And here the two values of u you get is u equals negative 1 plus root 5 over 4, and the second one is going to be negative 1 minus root 5 over 4. Okay. And you can just cos theta for both of them, negative 1 plus root 5 over 4, and cos theta equals to negative 1 minus root 5 over 4. Find the theta here. This is going to be cos inverse of negative 1 plus root 5 over 4. This gives you 72 degrees. This one gives you negative 1 minus root 5 over 4 gives you 144 degrees. And these three are going to be your answers for this question. For the next part, you're looking at functions where f is defined by this and g is defined by this. A is a positive constant. We need to find the expression of f inverse of x. Remember, it will still be in terms of a because we haven't really been given a value of a. And remember, for f inverse, you just need to write out the function f in terms of y. So x plus a squared minus a. And then you switch these two around. X equals to y plus a squared minus a, and then make y the subject. So take this to the other side. X plus a equals y plus a squared, and then square root. So square root of x plus a equals y plus a, and then you're going to just subtract by a. So square root x plus a minus a equals y. The only thing that's remaining to know is whether the sign on the square root is a plus or a minus. And I said this in my video that if it is a less than or equal to, it's going to be a minus. If it's a greater or equal to, it's going to be a plus. And so this is a less than or equal to, that means this is going to be a minus sign. Y equals to negative root x plus a minus a, and that's going to be your inverse for this. Okay. And then the next part is state the domain of that function. So the domain of the inverse, as I said, is the range of the original function. So what's the range of this function? The range of this function, remember, this is a quadratic, right? And the range is just obviously this is going to be a quadratic, which is a u, correct? And so the range is going to be the minimum point and everything above it, right? The minimum point here is negative a, because the vertex, remember, is going to be negative a, because we make the thing inside the bracket to be negative for the x coordinate, and for the y coordinate is just whatever is outside. So this is the minimum point, and so everything above it is a value that f can take up. So fx is greater or equal to negative a. This is your range for your f function, which will be your domain of your inverse function. So x greater or equal to negative a, that's your domain. And your range of the function of your inverse is just the domain of your original function, which is x lesser or equal to negative a. And so just going to write that here, f inverse is lesser or equal to negative a. So that's the range, which was the domain of the original, and this is the domain, which was the range of the original. Okay. Then, given that a equals to 7 over 2, solve the equation where we are putting f into g equals 0, right? And so we will need to find f of x first. F of x was x plus a squared minus a. Now a is 7 over 2, so x plus 7 over 2 squared minus 7 over 2. Yes, and we're going to put this thing, which is f, inside here. And so we're going to end up getting g of x plus 7 over 2 squared minus 7 over 2 equals 0. And the function of g is just 2x minus 1. So 2x minus 1. Therefore, this is just going to be 2. And in place of x, we're going to put whatever was inside here. And so x plus 7 over 2 squared minus 7 over 2 minus 1 equals 0. 2x minus 1, right? And then we can just solve this. So 2x plus 7 over 2 squared minus 7. Now you multiply this here and you multiply this here, and then you have minus 1 equals 0. It ends up becoming 2x plus 7 over 2 squared minus 8 equals 0. Take 8 to the other side. So 2 bracket x plus 7 over 2 squared equals 8. Divide by 2 on both sides. So x plus 7 over 2 squared equals 4. Square root, x plus 7 over 2 equals plus minus 4. Plus minus 2 here. And then take this to the other side. X equals negative 3.5 plus 2. And x equals to negative 3.5 minus 2. And with this x, you're going to get the first one to be negative 1.5 and the second one to be negative 5.5. Now, from these two, remember, I talked about composition in my video as well, where I said the x that you get has to be in the domain of the inner function. The domain of the inner function is x is lesser or equal to negative a. So x has to be lesser or equal to negative 3.5. And from these two, what is less than or equal to negative 3.5? This is definitely greater. And so this would be our only answer. This can't be an answer, so x is just equal to negative 5.5. That's going to be our answer for this. For this part, the diagram shows the curves with two equations, y equals to 2x power half plus 13x power negative 2, and y equals to 3x power negative half plus 12. And these two curves intersect at points A and B. Okay, so first you need to find what the coordinates of these points are. And remember, if you want to find coordinates at intersection, you just need to substitute. So 2x power a half plus 13x power negative a half equals 3x power negative a half plus 12. Yeah, and here you end up getting, just take this to the other side, take this to the other side, and you'll be getting 2x power a half plus 10x power negative a half, right? 13x power negative a half minus 3x power negative a half minus 12 equals 0. And here what we can do is we can write these in terms of square roots to make it easier to understand. So 2 root x plus 10 over root x minus 12 equals 0. We can remove the denominator, so multiply by root x on both sides, and we end up getting 2x plus 10 minus 12 root x equals 0. And this is another case of finding out quadratic equations, right? Here the power is 1, here the power is a half. This is twice of this. If you watch my video, this tells you that this is a quadratic equation, or you can change it to a quadratic equation, where you can first write this down as 2x minus 12 root x plus 10 equals 0. You can change it to au squared plus bu plus c equals 0, where u will just be root x. And so we end up getting 2u squared minus 12u plus 10 equals 0. And we can solve for u here. So 2, negative 12, and 10. This gives us u equals 5 and u equals 1. And so 5 equals root x and 1 equals root x. To find x, you just square both sides. And so x will either be 25 or x will be 1. And that gives us the two values that we were looking for. A would be 25, A would be 1, y coordinate something, and B would be 25, y coordinate something. Remember, we also need to find the y coordinate, so we can put this into either of these equations. Let's just put it into the first one. So 2 root x, y equals to 2 root x plus 13 over root x. And our x is 1, so y equals 2 root 1 plus 13 over root 1, which is just 2 plus 13, which is 15. And so here you're going to get 115. And then we can do the same thing with 5, and we're going to get, with 25. So 2 root 25 over 30 plus 13 over root 25, which is just 2 times 5 plus 13 over 5, which is just 10. 10 plus 13 over 5, which is going to be 12.6. Okay, so this is 25 and 12.6, or 12 3 over 5. Yeah, so this is for B and this is for A. Then the next part tells us what? Find the area of the shaded region. And here, if you notice, to find the area of the shaded region, which is just this part, we are taking the area under this graph, okay, which would go up to down, right? And we are subtracting it by the area under this graph. So the remaining will just be this extra thing. So we're taking the first curve, which is 3x power negative 2 plus 12, 3x power negative half plus 12, and then we are doing minus this part. So this entire thing minus 2x power a half plus 13x power negative a half. 2x power a half plus 13x power negative a half. Yeah, and these are our, this is what we need to find the area of. So area under the graph, remember, as usual, we need to integrate. Our limits will be a and b, so 1 and 25. So first we can just write this down properly. So 3x power negative a half minus 13x power negative a half, which will just give us negative 10x power negative a half plus 12 minus 2x power a half. And we are integrating this from 1 to 25. So we'll integrate this first. This will become negative 10 x power a half over a half plus 12x minus 2x power 3 over 2 over 3 over 2, and obviously 1 and 25. This is just going to become negative 20 root x plus 12x minus 4x power 3 over 2 over 3, from 25 to 1. Yes, and we're going to put both the limits in, so negative 20 root 25 plus 12, 25 minus 4, 25 power 3 over 2 over 3, and this entire thing we're going to subtract by, we put in 1, so negative 20 root 1 plus 12, 1 minus 4, 1 power 3 over 2 over 3, and we're going to do that. So this is just going to become negative 20 times 5, which is negative 100, plus 12 times 25, which is 300, and then this part, so 25 power 3 over 2 times negative 4 divided by 3, which is just negative 500 over 3. That's the first part, and then the second part is going to be negative 20 plus 12 minus 4 over 3. And so this is going to give us negative 100 plus 300 minus 500 over 3. This is going to be 100 over 3 subtracted by negative 20 plus 12 minus 4 over 3 minus by negative 28 over 3. And if you put them together, this is going to become 100 minus minus, so plus 28 over 3, so 128 over 3, which is just going to be our area under the graph, 128 over 3. Okay, and that's going to be it. For the last part, the equation of a curve of is y equals to f of x, where f of x is 4x power negative 3 power 5 over 3 minus 20 over 3x. Find the x coordinates of the stationary point. Remember, stationary point means dy over dx equals 0 of the curve, and determine their nature. So nature you determine by d square y over dx squared. Right? If it's greater than 0, it's a minimum. If it's less than 0, it's a maximum. Okay? So we're going to do that first. First find dy over dx here. Remember, dy over dx for this, if you guys know how to use the chain rule, and if you do it more times, you just know that you are taking this value right here, yeah, multiply it outside here, so 5 over 3, then take the derivative of the thing inside the bracket, which is just 4, multiply that as well, and then you just do the normal, so 4x minus 3 power 5 over 3 minus 1, which is power 2 over 3, and here it just becomes minus 20 over 3, and you want that to equal 0, correct? So 20 over 3, 4x minus 3 power 2 over 3 minus 20 over 3 equals 0. Take this to the other side, so 20 over 3, 4x minus 3 power 2 over 3 equals 20 over 3, and this is just going to be 1. Yeah, so this over 20 over 3 over 20 over 3, cancel, 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 this just becomes 1. And so we end up getting 4x minus 3 power 2 over 3 equals 1, which just means 4x minus 3 equals 1. Take this to the other side, 4x equals 4, x equals 1. So x equals 1 for the stationary point, and if you want the y coordinate, you just put your 1 inside here, so 4, 1 minus 3 power 5 over 3 minus 20 over 3 times 1. So 4 minus 3 is just 1, 1 power 5 over 3 is just 1, so 1 minus 20 over 3 is just going to be negative 17 over 3. So the y coordinate is going to be negative 17 over 3. Okay. Then you want to determine the nature of that point. Okay. So in order to find the nature of that point, we need to find the second derivative, and we would find the second derivative how? By doing second Just a small correction here, 4x minus 3 power 2 over 3 equals 1. This one, if you want to remove this power, you would first power it by 3, and you end up getting 4x minus 3 squared equals 1. And then if you square root it on both sides, so 4x minus 3 equals plus minus 1, right? And so 4x minus 3 equals plus 1, which will give us x equals 1, and 4x minus 3 equals negative 1, which would give us x equals negative 2 over 4, sorry, positive 2 over 4, which is just x equals a half. So your two x coordinates are x equals 1 and x equals a half. Now you need to find the second derivative to determine the nature, and this was our first derivative, right? And in order to find our second derivative, we would just 20 over 3 4x minus 3 power 2 over 3 and minus 20 over 3, and we're going to find the derivative of this as well again. So again, take this, multiply it here, take this, multiply it here, like the derivative inside the bracket, and then do it as it is. So 20 over 3 times 2 over 3 times 4, open bracket, 4x minus 3, 2 over 3 minus 1, yeah, because derivative, so negative 1 over 3, and then this just goes away, right? And so we end up getting 20 times 2, which is 40, times 4, which is 160, over 6, 4x minus 3 power negative 1 over 3. Remember, x is 1 and x is a half, so we put both the values in here. So 160 divided by 6 is just 80 over 3, and we're going to do both of them. So 80 over 3, 4, 1 minus 3 power negative 1 over 3, and 80 over 3, 4 half minus 3 power negative 1 over 3. And if you put these two in, so let me just do that really quickly, 80 over 3, open bracket, 4x minus 3 power negative 1 over 3, and if x equals 1, this is going to just be 80 over 3, and if x equals a half, this is just going to be negative 80 over 3. And so this would tell us that it's a minimum point, this would tell us that it's a maximum point. So when x equals to 1, that's a minimum, because it's it's greater than 0, so it's a minimum. And when x equals to a half, it is going to be negative 80 over 3, which tells us it's a maximum. Okay, so x equals 1, you have a stationary point, x equals to a half, you have a stationary point, the x equals to 1 is a minimum stationary point, the x equals to a half is a maximum stationary point. Okay, and then finally state the set of values for which the function of f is increasing. So if you want to see if a function is increasing, you need to find the set of values for dy over dx is greater than 0, which tells you that it's increasing, right? Increasing means it's just the gradient is positive, right? And so our dy over dx was this thing right here, 20 over 3, 4x minus 3 power, was it 2 over 3? Yeah, 2 over 3 minus 20 over 3. 2 over 3 minus 20 over 3, and we need this to be greater than 0. Take this to the other side, we end up getting 20 over 3, 4x minus 3 power 2 over 3, greater than 20 over 3. This just becomes greater than 1. So 4x minus 3 power 2 over 3 greater than 1. And then we end up getting, basically, this is an inequality situation. And so the way we do it, if you watch my video, we find the two values of x, which as we did before was 1 and x equals to a half, and we draw them on the number line. So we have a half here, we have 1 here, and we check for the points on either side, all of these, right? And basically we would start off with this side, so let's just put in 2 into this. So 4 times 2 minus 3, which is 8 minus 3, which is just 5, power 2 over 3. Is that greater than 1? Yes, it is. So 5 Power 2 over 3 is 2.9, so it's greater than 1, so this part stands. The middle part, let's just choose 0.75. Let's put that into this, so 4 times 0.75 minus 3, 4 times 0.75 minus 3, power whatever, 2 over 3, which is just going to be 0. And then, is 0 greater than 1? No, so this part is not there. And for any part here, so let's just put 0 here, where we're going to look at negative 3, so negative 3 power 2 over 3, that is 2.08, which is greater than 1. So this part also stands. And so our x values for which the function is increasing is any x which is less than a half and any x that is greater than 1. So these 2 points, or these two set of values, will give us an increasing function. For this next part, we need to find the coordinates of 3 points. This is your A, this is your B, this is your C, where P is a constant. The line AB is perpendicular to the line BC. Now what we know about perpendicular lines is that the gradient of one of the lines multiplied by the gradient of the other line is always equal to negative 1. And so if we find the gradient of AB and we find the gradient of BC, multiply them together, we are supposed to get negative 1. And so let's do that. This is your A, this is your B, this is your C. Find the gradient of AB, y2 minus y1 over x2 minus x1. So 7 minus 4 over P minus 6. And if you multiply that by the line BC, so 18 minus 7 over 14 minus P, that should equal to negative 1. And so this is just going to be 3 over P minus 6 times 11 over 14 minus P equals to negative 1. And we put them together. This is going to become 33 over P minus 6 times 14 minus P is just going to be 14P minus 6 times 14, which is 84, minus 84 plus 6P minus P squared equals negative 1. And then just take this to the other side. So 33 equals negative 1. 14P plus 6P is 20P minus P squared minus 84. This becomes 33 equals P squared minus 20P plus 84. Take this to the other side. 84 minus 33 is 51. So 0 equals P squared minus 20P plus 51. Then you can just solve this, and you would get P equals 17 and P equals 3. Now, as they said, given that P is less than 10, and from these two only this one is less than 10, so for this P would equal to 3. Okay, so now you have all your 3 points, and let's go to the next question. So a circle passes through the points A, B, and C. Okay, where A is 6, 4, I think, if I'm mistaken, right? B is 3, 7, and C is 14, 18. Okay, and what we have to do, first of all, we know an equation of a circle looks something like this. So x minus a squared plus y minus b squared equals r squared, where a, b is the center. Yeah, and so we could make equations like this for each of them. So here your x and your y, your x and your y, your x and your y. You can get 3 different equations. So 6 minus a squared plus 4 minus b squared equals r squared. Then you're going to get 3 minus a squared plus 7 minus b squared equals r squared. And here you're going to get 14 minus a squared plus 18 minus b squared equals r squared. And here obviously you can just substitute the r squared. So you're going to get 6 minus a squared plus 4 minus b squared equals 3 minus a squared plus 7 minus b squared. Yeah, and you can open the brackets here. So 36 minus 12a plus a squared plus 16 minus 8b plus b squared equals 9 minus 6a plus a squared plus 49 minus 14b plus b squared. B squared go away, a squared go away, right? And we end up with 36 plus 16, which is 52, minus 12a minus 8b equals 9 and 49 is going to be 58 minus 14b minus 6a. Yes, so if we put them all on one side, we end up getting 6 here. So 6 equals, take this to the other side, negative 6a and plus 6b. So negative 6a plus 6b equals 6. We can do the same thing for these two. We're going to get 9 minus 6a plus a squared plus 49 minus 14b plus b squared is equal to, expand this, so 14 squared is 196 minus 28a plus a squared, and then 10 squared is 324, so plus 324 minus 36b plus b squared. This and this cancel out, this and this cancel out, you're remaining with the rest. So 9 plus 49, 58 minus 6a minus 14b is equal to 196 plus 324, which is 520, minus 28a minus 36b. So minus 28a minus 36b. Keep them all on one side. 520 minus 58, we end up getting 462. That's equal to, bring this to the other side, so negative 6 plus 28, which is 22a, plus negative 14 plus 36, which is 22b as well. Okay, and we get this right here, two simultaneouses, and we can solve this. Let's just do that. Negative 6, 6, 6, 22, 22, 462, and we get a to be 10 and b to be 11, and so our center is 10, 11. Then from that we can find our r squared, right? So our radius we can find, so 6 minus 10 squared, which is just negative 4 squared, and then let me just change the color right here. Negative 4 squared, right? 6 minus 10 squared plus 4 minus b. So b in this case was 11. So 4 minus 11 is negative 7. So negative 7 squared equals r squared. So 4 squared is 16 plus 49. 16 plus 49, which is just 65. Yeah, and so r squared equals 65. And so our equation of the circle would just be x minus 10 squared plus y minus 11 squared equals 65. And that would be our equation of the circle. Okay. Next, find the equation of the tangent to the circle at C, giving the answer in the form dx plus ey plus f equals 0. Okay, so we have a circle. Okay, we have the center, which is 10, 11, and we have point C, which is 14 and 18, right? So probably somewhere here, which is 14 and 18. They're telling us to find the tangent. Now, what do we know about the tangent? Obviously, we could find the equation of this line right here, and the tangent is just perpendicular to that radius, right? And we can use that information to get the gradient of that tangent, because m1, m2 equals negative 1. So if we find the gradient of the radius, we can just use this formula to find the gradient of that tangent line. So let's find the gradient of the radius. 18 minus 11 over 14 minus 10. This just becomes 7 over 4. And if that's the radius of the, so that's the tangent, that's the gradient of the radius, then the gradient of the tangent you would just multiply by m2 equals negative 1 times 4 over 7 times 4 over 7. So m2 will equal to negative 4 over 7. So now we are at y equals to negative 4 over 7x plus c, and we can put in our points, which is 14 and 18 for the point c, and you have 18 equals negative 4 over 7 times 14 plus c, which will become 18 equals negative 8 plus c equals 26. So we basically have y equals to negative 4 over 7x plus 26, and obviously they don't want any denominators, so we can just multiply by 7 throughout. So times 7 times 7, and we end up getting 7y equals negative 4x plus 26 times 7, which is 182. And everything on one side, we end up getting 4x plus 7y minus 182 equals 0. And that's going to be the equation of our tangent. Yeah, and yeah, that is it for this paper.